Welcome to Lesson 20. This is where 19 lessons of manual work finally pay off. Everything you've configured by hand, Nginx, UFW, SSH hardening, fail2ban, AppArmor, Restic, Prometheus, we're now folding into one repeatable, agentless workflow that runs across your entire fleet. Ansible is declarative, idempotent, and only needs SSH plus Python on the target. By the end, you'll have inventory, your first production playbooks, and self-service pulls running clean. Install only happens in one place, your control host, whether that's your laptop or a Bastion. A simple apt install gets you Ansible core on Ubuntu 24.04, and the targets need nothing but the SSE access you hardened in Lesson 13 and a Python interpreter. Your inventory is just YAML grouping hosts by role, web, DB, monitoring, and once Ansible all ping returns pong across the fleet, you're ready for ad hoc commands, one module, one group, 0 playbooks. Perfect for uptime checks or pushing an apt cache refresh before you commit anything to code. Once ping works, you graduate to a playbook, and this is where the magic compounds. Site.yaml is just YAML. A play targets all hosts, becomes root via the sudo you set up in Lesson 15, and runs a list of tasks. Each task calls a module. Apt to install UFW, failban, Restic, and unattended upgrades in one shot, then community.general.efw to replay your Lesson 12 firewall baseline, then a copy to harden SSD from Lesson 13. State, present is the key word, idempotent. Run it once, run it 50 times, the box ends up identical. Every new host hardened the same way, from a single file. But a single playbook doing 5 things gets unwieldy fast. Roles are the unit of reuse. Ansible Galaxy init Nginx scaffolds the whole layout for you. Tasks, handlers, templates, defaults, vars, meta. Your Lesson 7 Nginx setup becomes a role. Apt installs the package. A Jinja template renders nginx.conf, and notice the validate line. Nginx T checks the config before it's even written, so a typo never takes the site down. Then site.yml just lists roles. Nginx, failban, Prometheus, share exporter. Compose, share via Git or Galaxy, done. Now the same role needs to behave differently in dev, staging, and prod. Different ports, FQDNs, backup buckets. That's group vars and host vars. Drop a web.yml under group vars, and every host in the web group inherits it. Drop web1.eml in host vars, and you override one box. Precedence flows left to right. Role defaults lose. The ECLI flag wins. In secrets, never plain text in Git. Ansible Vault create encrypts the file. Ansible Vault edit reopens it, and your Restic password from Lesson 18 ships safely alongside the playbook. Now flip the model entirely. Instead of a control host pushing to thousands of targets, each host pulls its own config. You install Ansible core and Git on every machine, point ansible-pull at your Git repo, and it clones, runs site.yml locally, and reports back. Wrap that in a system timer firing hourly with a 30-minute randomized delay so 1,000 boxes don't stampede Git at once. And suddenly drift correction is self-healing, with no master to fail. Bookmark this slide. It's 95% of what you'll actually type. Always pre-flight with your syntax check and check. Diff before touching anything. Scope rollouts with limit and tags, so a bad task hits one host, not the fleet. Reach for VVV, Ansible inventory, list, and the setup module when things go sideways. An Ansible Galaxy install pulls battle-tested roles like Geerlinguy.nginx straight from the community. No need to reinvent what we hand-built back in Lesson 7. Now, a reality check. Ansible isn't the hammer for every nail. For 5 to 500 Linux hosts, push mode is unbeatable. Agentless and idempotent. Cross 1,000 hosts and you flip to Ansible-pull with Git so machines self-apply hourly. Provisioning cloud VMs? That's Terraform's job. It tracks state, Ansible doesn't. Containers belong to Kubernetes, and quick one-liners to ad hoc shell. The production answer is hybrid. Terraform provisions, Ansible configures, K8 runs the apps, and Prometheus from Lesson 19 watches it all. And honestly, what we've covered today is just the on-ramp. If you want to go deeper, writing custom Python modules, dynamic inventory pulling live from AWS or Hetzner, Molecule for role testing, AWX for a multi-user web UI, and migrating off Puppet or Chef, there's a dedicated 13-lesson Ansible Mastery course on Dargslan.com that picks up exactly where this lesson stops. Think of it as the deep dive once these patterns feel natural in your fingers. Before you go off and automate everything, let me save you some pain. 5 gotchas that have bitten me or people I trust. Number 1 is the big one, forgetting. Limit and shipping a breaking change to all 200 hosts at once. The fix is muscle memory, always. Check first, then one host, then one group, then 10%, then all, and bake serial 25% into the playbook itself. Number 2, never put your vault password inside the repo. Keep it in /etc. git with a pre-commit hook catching mistakes. 3, handlers fail silently on typos. Verify with -v or flush them explicitly and run Ansible lint. 4, the shell module breaks idempotency. Use creates, removes, or better, a real module like user or line and file. And 5, when your inventory hits 500 hosts, bump forks to 50 or 100, try strategy free, and look at mitagen for a 10x speed up. So here's where you stand after lesson 20. 6 skills that turn 19 lessons of manual work into code. You write inventories and fire ad hoc commands. You build idempotent playbooks with handlers. You compose reusable roles. You manage variables with vault encryption and a clear precedence model. You let hosts pull their own config on a system timer, and you ship changes through a safe rollout funnel. Nginx, UFLW, SSH hardening, fail2ban, AppArmor, Restic, Prometheus. All of it is now reproducible across the whole fleet. Next lesson, we go into container runtimes. Docker, Podman, Rootless, and Quadlet. Lesson 20 is in the bag. Your fleet is automated, agentless, and reproducible. Next up, lesson 21 shifts gears into container runtimes. Docker versus Podman, Rootless by default, and Quadlet for systemd native units that finally retire Compose. It builds straight on the LXD comparison from lesson 8, so you'll see exactly where containers fit alongside everything you've hardened so far. Run next lesson, and I'll see you in 21.